FBA 310, Statistics 2, Study Section 2. The A part is correlation. My name is Dr. A.I. Opara and my email address is indicated here. Introduction. What is correlation? Correlation is the association or relationship between two or more variables, while correlation coefficient measures the degree of that association. Real-life examples of correlation include things like improved workers' pay and productivity, and advertisement and sales. That is, if you increase advertisement and make some more sales, that means advertisement is related to sales. Why is correlation important? Correlation is important because scientists, business executives, and other policy makers are interested in correlation. And why are they interested in correlation? Because it enables them to manipulate one variable using another. By this, we mean if advertisement is correlated with sales, then it makes sense to increase advertisement in order to record increased sales. And also, you will use correlation as a tool for analyzing your research projects in year 5. Learning objectives. When you have studied this section, you should be able to draw the Cartesian coordinates as scatter plots, state with illustration the various types of correlation, and compute the Pearson's correlation coefficient. Let us discuss the Cartesian plane and Cartesian coordinates. The Cartesian plane is a graph sheet, and for you to use it, the first thing is draw the y and x axis. The y-axis is here. This is the positive part of y, and then this part is the negative part of y. This is the positive part of x, and on the left is the negative part of x. A point on the Cartesian plane can be represented by two values. For instance, point A is represented by 5 on the x-axis and 10 on the y-axis. Point B is represented by -10 on the x-axis and 30 on the y-axis, and so on. We can use the Cartesian plane to represent bivariate data. Bivariate means two variables, x and y. Look at this value, 3 for x and 14 for y. It can be represented on the Cartesian plane by going to where x is 3, that is here, going up to meet where x is 14, that is a little bit below 15. So we put a point or a star here. The second point is 4 for x. We go where x is 4 and go up to meet where y is 10 and put a point or a star. Similarly, we represent all the points. Then we have all these points trending upwards to the right. It is a scatter plot. A scatter plot can tell us something about the correlation. Types of correlation. If a scatter plot is drawn and it shows a wave of points going upwards to the right, then it's indicative of positive correlation. If all the points on the scatter plot falls on the same line and still trending upwards to the right, it is indicative of perfect correlation. Perfect positive correlation, the value of it is 1, and correlation that is positive but is not perfect, the values range between 0 and 1. Now, negative correlation, the scatter plot indicates the points trending downwards, but they are not on the same line. But for negative perfect correlation, the points fall on the same line, and the value of the negative perfect correlation is -1, while negative correlation, which is not perfect, is between 0 and -1. That means that correlation coefficient comes between -1 and +1. It can be greater than 1 and it cannot be less than 1. Any value of correlation more than 1 means that there is a mistake somewhere. Types of correlation. We see that for zero correlation, when form a horizontal band along the x-axis, then that is indicative of zero correlation. Now, all these indications of correlation by scatter plot, we can even do better. We can examine the data without plotting a scatter plot to get an idea of the type of correlation we have. A zero correlation, the pattern of increase or decrease of y is not accounted for by increase or decrease in x. Suggested levels of correlation. Correlation can be high or low. These figures give indications of high and low correlation. High positive correlation is when the correlation coefficient falls below 1.0, while low positive correlation between 0.1 to 0.5. High negative correlation, above minus 1.0 to minus 0.5. Let me explain. Above minus 1.0 are figures like minus 0.8, 0.9, and so on. Low negative correlation is above minus 0.5 to minus 0.1. Positive perfect correlation is 1, and negative correlation is minus 1. Then zero correlation is when you get a correlation coefficient of 0 or near 0. Now, how do we calculate correlation coefficient? Pearson has given us a formula, and Pearson's correlation coefficient is called R. R is equal to SXY all over S subscript XX and S subscript YY. SXY is sum of X minus X bar multiplied by Y minus Y bar. Also, SXX is sum X minus X bar squared, and so on for Y minus Y bar. Now, Pearson's correlation is called parametric correlation simply because there's an assumption that X and Y are normally distributed. Let us implement the above formula that we have given. Given bivariate data X and Y, which you see here, see the values X and then see the values Y. For x3, y is 14. x4, y is 10. First of all, calculate sum of x, calculate sum of y. Then find the mean of x, which is 6.0, and mean of y, which is 16.0. Then this mean of x, use it and come here. 3 minus mean of x, that is 3 minus 6, is equal to minus 3. You can see it here. 4 minus 6 is minus 2, which you can see here, and so on. If you get all these values, square each of them. That's how we get the values that are here. When you then sum these squares, you have got sigma x minus x bar squared. Then with the mean of y, you come to y. 14 minus 16, that's how we got minus 2. 10 minus 16 minus 9. When you square all these, that's the values we have here, and their sum is 122. For x minus x bar multiplying y minus y bar, you come here, this is x minus x bar, y minus, just multiply two of them. So hence we have minus 3 times minus 2, which will give us positive 6. Minus 2 times minus 6 will give us positive 12, and so on. When you sum up all, then it is the sum of x minus x bar multiplying y minus y bar. Then to calculate the correlation coefficient, all you need now is bring these values into this place. SXX is 34 and SYY is 122. You plug these figures in here, then find square root of this product, then use it to divide this. We have this. That is Pearson's correlation coefficient. You will see that this is high positive correlation, meaning that X and Y are highly positive correlated. Now, the method we have discussed, there is a problem with it. Method B. The method described earlier, it's good, but if this subtraction involves decimal places in the mean of X, the subtractions can be very messy. So to avoid such messy subtractions and then squaring, we now redefine SXY, SXX, and SYY. SXY is equal to sum of XY minus sum of X multiplied by sum of Y divided by N. SXX is sum of X squared, that is square the X's before adding. And then here is square the sum X's before squaring. Then sum SYY. To use this formula is useful when X bar or Y bar are not whole numbers. It makes the work easier. Here, what we do is this is X, this is Y. So we square the X's, these are the values, square the Y's, these are the value, then the cross product XY, that is multiply X by Y, we get 140. We have the sums. Then we carry the sum to this place for convenience. Then SXY is sum of XY minus sum of X multiplied by sum of Y over N. And we pick these figures from here, plugging into this formula, then simplify and have the answer as minus 49. Then SXX is sigma X squared, here is sigma X squared, minus sigma X all squared, that is 31 squared, and get the answer. Similarly for SYY. Then when you have done all these computations, you then bring the value of SXY here, SXX here, and SYY here. That's how we have this value, which is this. And this is indicative of high negative correlation. Now, with this, we have come to the end of Pearson's correlation. We have Spearman's correlation, which will be taken up in another lecture. And for now, we have an assignment to attempt. That is assignment 1. And there's also assignment 2. Practice with these two problems and try it applying both method A and B. Thank you very much for listening. The end.